There are some more problems. That is, 1 gram of graphite is burn burn in burnt in bomb calorimeter in excess of oxygen at 298 Kelvin and 1 atmosphere pressure. That means graphite means what? Carbon. Carbon undergoes combustion with excess of oxygen. Then we get CO2. During that reaction, temperature rises from 298 Kelvin to 299 Kelvin. We know that. Heat capacity of the bomb calorimeter is 20.7 kilojoules. Heat capacity also given per Kelvin. What is enthalpy change? Nothing but change in enthalpy for the above reaction at 298 Kelvin temperature and 1 atmosphere pressure. So in that question, what are given? Heat capacity is given, temperature is given, pressure is also given, one reaction is given. What we have to find? Change in enthalpy. That means delta H is to be found. Before finding delta H, we have to find delta E. Why this experiment is done in bomb calorimeter? In case of internal energy, we saw one point, that is what? By using bomb calorimeter experiment, we can find delta E. So before finding delta H value, we have to find delta E value. What is the relation between delta H and delta E? Delta H equal to delta E plus delta nRT. In this case, delta n value is 0. What is delta n? Delta n equal to np minus nr. That means 1 minus 1. This is in solid state, so no need to consider. If delta n is 0, automatically delta H equal to delta E. That means if you find delta E value, automatically that will be delta H, because both are same in this equation. So what we have to find? Delta E. Delta E means what? Change in internal energy. That can be found by using bomb calorimeter experiment. Along with that, heat capacity is given. What is the formula we have to use when heat capacity is given? We have to use this formula. Q is equal to m into S into delta T, where m is mass of the system, Q is heat applied to the system, delta T is rise in temperature. Then what about S? S is what? Specific heat. S is what? Specific heat. But here heat capacity is given, specific heat is not given. Why we should consider this one? If you read this question carefully, then you get clear idea. Here 1 gram of graphite undergo combustion, then temperature rises from 1 degree centigrade. That means from 298 Kelvin to 298 Kelvin. For that, heat capacity is given. That means indirectly specific heat is given. What is the meaning of specific heat? 1 gram of substance, temperature rises to 1 degree centigrade. 1 gram of graphite is given. That means specific heat is given indirectly. So this heat capacity in this question is equal to specific heat 20.7. Delta T is what? 1. Delta T means what? Change in temperature. 298 minus 298, how much? 1. Then what about 12? 12 is mass of the system. Here system is what? Graphite, nothing but carbon. Carbon mass is how much? 12. Then you can find Q value. After finding Q value, you have to learn one point. You have to know one point, that is, in bomb calorimeter experiment, every time combustion takes place. See, this is the example for combustion. Combustion means what? When any substance reacts with oxygen, that is called combustion. See, during combustion process, heat releases. We got how much heat? This much heat. That is minus 248. Here negative sign indicates what? Releasing heat. Negative sign indicates what? Releasing heat. Positive sign indicates what? Absorbing heat. We know that exothermic, endothermic. Already we have seen all those reactions in class 10. So here delta E will be how much? Delta E will be minus 248.4. Automatically delta H is equal to minus 248.4, because both will be same. Why both will be same? In this case, delta n will be 0. If delta n will be 0, automatically delta H equal to delta E. That is the way to solve the questions regarding this model. And one more question is there, that is, if water vapor, nothing but gases, is assumed to be perfect gas, nothing but ideal gas. Molar heat, molar enthalpy change, nothing but delta H per mole, delta H per mole. For evaporation of 1 mole of water at 1 bar and 100 degrees centigrade is 41 kilojoules per mole. That means molar enthalpy change is given per mole. Enthalpy change is given per mole, that is 41 kilojoules. Along with pressure and temperature is also given. Calculate internal energy change, that means delta E. That means delta H is given, we have to find delta E. When 1 mole of water is vaporized at 1 bar and 100 degrees centigrade. And one more case, 1 mole of water liquid is converted into ice. So in this question, change in enthalpy is given, pressure is given, temperature is given. We have to find what? Delta E. Delta E. When 1 mole of water is converted into vapor, that means 1 mole of liquid is converted into vapor, and 1 mole of liquid is converted into solid. 1 mole of liquid is converted into vapor, we have to find delta E. And also when 1 mole of water is converted into solid, then also we have to find, ice means solid, then also we have to find delta E. First condition for this question, this is the suitable equation. How can we say that 1 mole of water is vaporized, means evaporation, that means liquid is converted into vapor. That means in this case water is present in liquid state, in this case water is present in gaseous state. In this case delta N is what? Np minus Nr. Every time delta N is Np minus Nr. Np means number of gaseous products. This is gaseous product 1. But here no gaseous reaction, so that it will be 0. 1 minus 0, 1. Then delta N is positive. We found delta N already. From that we can find delta E. How? Delta H equal to delta E plus delta nRT. From this delta E equal to what? Delta H minus delta nRT. Delta H is given already, 41 kilojoules minus 8.3. 8.3 means what? Delta H value. Sorry, 8.3 means R value. 8.314 joules. But here delta H is given in kilojoules, so it is also to be converted into kilojoules. 8.3 into 10 power minus 3. T value how much? 100 degrees. It is always converted into kelvins. 100 plus 273, 373. Delta N is what? 1. If you substitute all these values, then you can find delta E value. That's it. That is the way to calculate delta E value. Next, second condition is what? 1 mole of water liquid is converted into ice. That means solid is converted into, liquid is converted into solid. Here there is no gaseous reactant, no gaseous product, then delta N will be 0. If delta N will be 0, delta H equal to delta E. Already delta H is given, that will be equal to delta E, that is 41 kilojoules. So that is the way to find out delta E or delta H. You have to read the questions carefully, then you will get clear idea. This is all about numericals based on heat capacity, specific heat, and first law of thermodynamics. Thank you.